In this video, we will be covering Hobart Brothers LLC Senior Design Project with the Material Science and Engineering Department, covering thermal processing of aluminum rod with scandium for wire drawability. This team includes Sonja Blickley, Tori Nizzi, Anna Palmcook, and Austin Schaub.
Hobart Brothers LLC has been looking into adding scandium and zirconium to aluminum weld wire to create AL5025 and a step to supply material for wire arc additive manufacturing, also known as WAM. In aluminum alloys, scandium groups into small particles known as Al3SC dispersoids that inhibit dislocation movement and strengthen the wire. Dispersoid size can be controlled by thermal processing of the alloy, where the strength peaks at a specific dispersoid size and then decreases as the dispersoid continues to grow during overaging. In the past, Hobart has had issues with material fracture during wire drawing, as peak-aged 5025 is not ductile enough to undergo the wire drawing process. The problem addressed in this project involved identifying an overaging thermal process for the 5025 rod that allowed for drawability. A secondary problem was also addressed involving subsequent dissolution of Al3SC dispersoids during WAM, so the printed part could be thermally processed for increased strength.
In order to identify the best thermal process to allow for drawability, mechanical, conductive, and microstructure characteristics of peak-aged and overaged Al5025 rod had to be quantified. Thermal treatments for both conditions were known from previous Hobart wire drawings. Tensile testing and Bicker's microhardness were used to identify the relevant mechanical properties, while a 4-point probe was used to measure rod conductivity, and scanning electron microscopy allowed for dispersoid identification. The most intensive part of our solution was measuring dispersoid size of the samples at a nanometer scale using transmission electron microscopy.
The team concluded that slow-cooled aluminum 5025 rod could be used for wire drawing, as it displays the mechanical behavior and material characteristics consistent with the previously drawable thermally processed rod. Additionally, we concluded that WAM of aluminum 5025 wire with a peak heat of 1,350 degrees Celsius was acceptable to resolutionize scandium from aluminum 3 scandium dispersoids to a degree where subsequent heat treatment results in an increase in strengthening shown through our hardness results.
Our recommendation for Hobart moving forward is to verify that the slow-cooled thermal processed rod would be able to undergo wire drawing. We would also recommend creating both small-scale WAM prints with the slow-cooled material to verify dissolution of SC and large-scale WAM prints to research how the mechanical characteristics changed with large-scale thermal processing.